In comparison to old technology aircraft, the flight deck on the A320 is designed to be a comfortable, uncluttered environment in which to work. By utilizing modern electronic display units, the presentation of information to the pilots has been improved. The Electronic Instrument System, EIS, consists of 6 identical full-color cathode ray tube display units. The EIS is divided into 2 subsystems. The Electronic Flight Instrument System, EPIS, for which each pilot has 2 displays. The Electronic Centralized Aircraft Monitoring System, Ecam, which uses the 2 displays in the center to provide information on the aircraft systems. Let's look at the Eepa system first. The 4 EPIS displays provide the pilots with flight data to help them operate the aircraft in a safe and efficient way. Flight parameters are displayed on primary flight displays, PFDs, while navigation data is displayed on navigation displays, NDs. Each pilot has an EPIS control panel to select what is displayed on the EPIS screens. The EPIS control panels are divided into 2 sections, one section associated with the PFD and the other with the ND. Outboard of the PFD, there are control knobs to adjust the brightness of the associated PFD and ND, or to turn the display off. A switch is provided to allow the information on the PFD and ND displays to be transferred. The 2 displays in the center are dedicated to the Electronic Centralized Aircraft Monitoring System, Ecam. The upper Ecam display is known as the Engine Warning Display, E/WD. The lower Ecam display is known as the System Display, SD. It is on this screen that various aircraft system parameters can be viewed by the pilots. As an example, we will cycle through the system pages for you. The presentation of system information is based on a need-to-know philosophy. This means that only the system information relevant to the particular phase of flight is presented to the pilots. You will see this demonstrated in the normal and abnormal operation modules. Another philosophy that is used on the flight deck is the lights out principle. What this means is that when the aircraft is in its normal flight state, there will be no white lights illuminated in any of the switches on the overhead panel. Let's look at some switches and show the different possibilities. For the majority of the switches on the overhead panel, the push-button switch logic is normal operation configuration, no light showing, the lights out philosophy. Abnormal condition, amber fault light. This assists identification of the switch associated with an abnormal condition. Non-lights out switch position, white light. If normally the system should be operating and is deactivated, a white off light is illuminated. If normally the system should not be operating and is activated, a white on light is illuminated. There are some switches on the overhead panel which are used on a temporary basis or may have an indication of their state. The logic is temporary selection for operational reasons, blue on light such as anti-ice. applicable system status, green light, such as APU available. Below the Ecam displays on the center pedestal is the Ecam control panel. The two controls on the left-hand side are to adjust the brightness of the two Ecam screens or to turn them off. We will look at the rest of the controls on this panel in more detail later. Just below the Ecam screens on the pedestal is a switching panel for use in abnormal situations to restore data to the Eepa and Ecam displays. In front of each pilot, there are two attention getters, a red master warning and an amber master caution. As a further means of getting the pilot's attention, there is a loudspeaker on each side of the cockpit for oral alerts and voice messages. Note, the loudspeakers can also be used to listen to ATC and the intercom. Now, let's go back to the Eepa system. For the Eepa displays, data from the Air Data and Inertial Reference System, ADIRS, plus navigation data from the Flight Management and Guidance System, FMGS, is fed directly to three Display Management Computers, DMCs. The three identical DMCs process the data and generate the images to be displayed. Under normal circumstances, DMC-1 supplies Eepa information to the captain's PFD and ND. DMC-2 supplies the first officer's PFD and ND. DMC-3 is available as a backup. Now let's look at the other EIS subsystem, Ecam, and how the Ecam displays get their data. Sensors are fitted throughout the aircraft to monitor the various systems, including system controls operated on the flight deck. Data for certain parameters, for example, fuel quantity and primary engine indications, is routed directly from the system sensors to the three DMCs. Note that there are separate channels within each DMC for Ecam and Eepa. For a majority of the systems, the sensors supply data to two Systems Data Acquisition Concentrators, SDACs. The SDACs acquire system data, process it, and send system page data to the three DMCs. Normally, DMC-1 supplies the engine warning display. DMC-2 supplies the SD, the system display. Two identical flight warning computers, FWCs, receive data from the aircraft system sensors to generate red warnings, the SDAC to generate amber cautions. The FWCs then supply the DMCs for the display of alert messages, the attention getters, the loudspeakers for oral alerts, and synthetic voice messages.
Speed, speed, speed.
All the components shown can be collectively called the Ecam system. We will study the use of the Ecam system in a separate module. The master time reference for all aircraft systems is provided by a clock located on the right lower side of the main panel. The time is also displayed at the bottom of the system display. The two chrono push buttons, located on the glare shield, control the associated display on the individual NDs. The chronos operate as stopwatches, measuring either seconds, minutes, or hours.